Since our last video on this topic, a lot has changed. AMD took the CPU core wars to the next level, Nvidia turned RTX on, and Apple dropped the new Mac Pro. But has RAM usage changed? Do you, Wanda, really need 1.5 terabytes of RAM? Or will just a dab do ya? To find out, we tested a variety of workloads. Everything from opening browser RAMs in Chrome, browser tabs, to high-resolution gaming, to 4K video editing, to complex flow simulation on a single 4 gig stick of RAM, the smallest available for DDR4, all the way up to a monstrous 256 gig kit, and everything in between. And how much do you need? Well, as always, the answer is, it depends. And as always, here's a segue to our sponsor, Xsplit. Xsplit makes powerful streaming PC apps for streamers, vloggers, and more. Check out their VCam app to change or blur your background without a green screen. We're gonna have that linked below. Just like last time, we're gonna track page file usage with Performance Monitor and open up tasks until we notice activity in the page file. That threshold, where the system starts to swap data out of RAM and onto the boot drive, is important. Not because you would instantly see your system slow down to a crawl, but because that's where you could see a dip in system responsiveness when switching between apps, or even an increase in load times for programs that have been paged to your SSD or hard drive. Before we begin though, I want to talk through one of the most important choices for a video like this. For our CPU, we went with the 24-core AMD Threadripper 3960X because it allowed us to test every one of our RAM configurations on the same ASUS Zenith 2 Extreme motherboard, eliminating that as a variable. We also went with that because we wanted a system that was reasonably representative of what will become available to general consumers over the next few years. We could have plunked a 64-core processor onto that same motherboard, but that ain't going mainstream. While the way things are going, 24-core actually might. Thanks, AMD. We went with an RTX 2080 Super graphics card, a Corsair MP600 1TB boot drive, and a variety of Corsair Vengeance memory that was chosen simply because Corsair has an incredibly broad memory lineup that covers any config we could want, and they sent it over to us. At 4 gigabytes, everything is about as you would expect. We're sitting at around 50% usage after logging into Windows before we've even done anything. Simply opening Chrome and watching a 4K YouTube video immediately pings the page file, crossing our threshold. If you avoid video, the good news is that you can open 6 to 7 tabs of various text and image-based sites before you see page file use, and we got to about 125 tabs before Chrome decided it had had enough and completely pooped itself. 8 gigs was much better. We comfortably handled 3 4K videos from YouTube and 27 tabs at the same time before we saw any page file usage. 630 tabs later, we saw the system become unresponsive and laggy anytime we tried to load or reload a page. Maybe on Linux 4 gigs would be okay, but 8 gigs looks like the lowest we'd recommend for a good Windows 10 experience. With 16 and 32 gigs, we stuck with the 3 4K YouTube videos, can only watch so many videos at the same time, and made it to 430 and 730 other tabs respectively before tapping that page file. Now, Chrome wasn't very happy when we hit our max tabs in either case, but as long as we didn't touch anything else, the computer was actually still usable. It's safe to say that anything beyond this is pretty much colossal overkill. On to the games. Shadow of the Tomb Raider calls for 8 gigs of RAM for its minimum spec and 16 for its recommended spec. Rainbow Six Siege wants 6 gigs of RAM minimum and only 8 gigs recommended. And finally, we've got Csgo that needs just 2 gigs of RAM. Just 2. Can basically run on an overclocked potato at this point. All of our games were run at 1440p and the highest settings, with no motion blur obviously. Starting at 4 gigs of RAM, Csgo, well, as advertised, ran just fine at 278 frames per second with no noticeable issues. But while both Tomb Raider and Siege seemed to run well at 90 and 154 FPS respectively, what's interesting here is that these great looking numbers did not translate to a great gameplay experience due to occasional frame rate dips. Both games reached about 60% page file usage, so I think we know what to blame. Tomb Raider jumped to 103 FPS when we switched to 8 gigs of RAM and smoothed out considerably with almost no stutters or hitching to be seen. And Rainbow Six also improved to 155 FPS, so okay, not really. But just like Tomb Raider, all the stuttering was gone. Csgo added a whopping 6 frames, but sarcasm aside, it was a solid experience with no issues, as we'd expect. So 8 gigs then is still plenty for gaming? Well, here's the thing. On a sanitized benchmarking Windows install, nothing else is gonna be running in the background. That's not representative of the real world. And when Tomb Raider and Siege were running, they were using 7 to 7.5 gigs of RAM, and the page file hit 20% usage on occasion. So having Chrome, Discord, and/or a music app open in the background would likely affect performance to some degree. Fortunately, moving up to 16 gigs gives us plenty of room to work with, just like there's plenty of room in your closet for our merch, ltdstore.com. Average frame rates either stayed steady or improved, and we had plenty of headroom to record our gameplay or stream in the background. Past this point though, there was no real performance gain or loss. Adobe Premiere cut 4 and 8 gigs down pretty quick, with the 4 gig setup crashing on a regular basis anytime we tried to render just a 1-minute test clip. And as for our 8 gig config, it did manage to render the clip, but it took a hot minute, as the kids say. The video that we're using is a mix of edited 4K and 8K footage from one of our past videos. At 16 gigs, Premiere was usable, with our render taking just 3 minutes and 23 seconds, but scrubbing and playback was like watching an old movie picture reel. Remember guys, this is on a Threadripper and at both 1/4 and 1/8 scale. So we'd say this is okay as long as you're willing to wait around to create proxies before you edit. So those are lower resolution versions of your clips, or if you stick with 1080p. 32 gig and beyond is gonna help bring your render times even lower and work with much larger and more complicated project files. A lot of the usage here though is gonna come down to your individual workflow needs. Our editors Mark and A Prime have slightly different machines, with Mark's having 64 gigs of RAM and Prime's having 128. Both of them have Premiere, After Effects, Photoshop, Chrome, Word, and Excel open while editing a video, and depending on the video, Mark will see 85 to 95% usage while he edits, and A Prime will see 60 to 70%, sometimes spiking to 90% utilization or 115 gigs. Now up until this point in the video, I would forgive you for thinking that 256 gigs is overkill for anything. But while nothing that average folks are likely to do will ever touch it, engineers and scientists will often have huge amounts of data to deal with, to the point where such a system loadout might not even be a luxury, but rather a necessity. Check out our RAM Punisher flow simulation benchmark. The more memory you have, the more variables you can account for, improving the airflow calculations around this Cybertruck model. This thing can easily suck up 256 gigs of RAM and actually prefers to have more. Shout out to FlowJo, by the way, for this benchmark. Another example is a professional composer and mixer like Neil Parfit, who regularly has projects reach upwards of 215 gigs thanks to all of the tracks and instrument sets that he needs loaded. Having them in memory means instant access. Now, one thing our test was not able to account for today was the increase in memory bandwidth as we scaled from single channel to dual and quad channel configurations. That's why we focused on page file usage as our threshold rather than on the performance differences. But stay subscribed, because that is something that we would like to explore going forward. So then, in the end, conclusion. You're probably fine with just a solid 8 to 16 gigs of RAM for your everyday use and gaming. If you do photo and video editing, bump that up to 32 or 64 or 128 if you do it professionally. And beyond that, well, it's probably just bragging rights, unless you know for a fact that you're doing something that benefits from it. Which, you know, we're not judging. Bragging rights is okay too. Just like you'll have bragging rights by switching to our sponsor, Xsplit. Xsplit's VCam allows you to remove, replace, and blur your background without a green screen. It works with any webcam, and there's no need for complicated lighting setups. It uses AI to automatically know the difference between you and your background and allows you to customize your background to anything you want. VCam works with other XSplit broadcast tools, but also OBS, Slack, Hangouts, Skype, and more, and they've got 24/7 support with lifetime updates. It costs as little as $9.95 US for 3 months, and a lifetime license is available for just $40. Use offer code LinusTechTips, we're gonna have that down below, to get 10% off. All right, if you guys like crazy RAM videos, maybe check out our recent one, opening up Chrome tabs on a system with 2 terabytes of RIDE. It's a wild and sometimes very tedious ride. But don't worry, we cut out the tedium. It's a fun video. Stop! What do you people want? Everybody's messaging me.